Hello everybody and welcome to this webinar where we're going to be taking a look into how data science can enable digital transformation in your organisation. We'll be exploring what data science is and how it's influencing better decision making in businesses. As a result of the pandemic, every organisation is experiencing a move towards a more digital world. And as part of that shift, recognising that the power of data is becoming increasingly crucial to any business worldwide. And that's why today's session will be relevant to every one of us. I'm Sally and I'm the Sales Director here at ILX, and I'm joined by Alice from our marketing team and also Armando, who is a data science strategist as well as a lead trainer at Simplilearn and has 20 years of technology industry experience. We've prepared today's session so it's relevant to those of you that are new to data science and also for those of you that are more experienced. But before I hand you over to Armando, I just wanted to run through a couple of housekeeping notes. It won't take long, and also share a little bit of information on ILX and Simplilearn partnership, just in case you're new to us. Okay, so first of all, this session is recorded. So if you need to nip out or you want to forward this recording to a colleague, we'll be emailing you the recording tomorrow, so look out for that in your inbox. We've scheduled 1 hour for this session, so we're allowing 10 to 15 minutes for questions and answers at the end of the session. Please, if you can mute yourself so there's no disturbance on the line, that would be much appreciated. And if you're not already doing so, please follow us on any of these social media platforms that you see on the screen. We're constantly posting really good stuff, whether it's a podcast, a blog, a white paper, or a webinar. And if you have got questions that you want to ping over to us as we're going through the presentation, you'll see there's a chat box to the right. So please submit your questions. Alice can collate those at the end, and we can go through as many of those as we possibly can. And then last but not least, we are a learning and development business improvement business. And we are really hoping that today's session will inspire you to go back and do something different back in the workplace. So we encourage you to take notes and turn those notes to action. Okay, so it's probably helpful for you to understand a little bit about the ILX and the Simplilearn partnership. ILX is an international accredited learning provider, and we're a specialist in improving capability in project management, service management, and agile disciplines. And Simplilearn are a leading global online edtech business. And it's through our partnership where we can provide online learning solutions that cover a wide range of technical disciplines. So whether or not it's data science, AI, project management, big data, cloud computing, IT service management, to name a few, we can support you on those needs. And right now, more than ever, upskilling is seen as a must, so businesses can move forward and really embrace this digital economy. So whether you're looking to develop a team of highly skilled data scientists, or whether or not we're probably a more outcome-centric, highly engaging learning program would be more appropriate, or whether or not you're looking for a light touch introduction to data science as an example, we can cover all of those needs. And it's our combined 40 years experience that's proven that our approach improves learning outcomes, it really engages the learners and drives better performance. So hopefully that gives you a sort of a sense of our organisations and our approach to learning and upskilling. And I think now is probably a good time to hand you over to Armando, who's going to talk data science. So thank you for listening. Armando.
Excellent. Sally, thank you very much. And it's a pleasure being here and try to, get all of you and all our attendees excited about data science, and especially mentioning why it's so important, and not so important, it's fundamental for every business in this new digital era. Okay, so as Sally mentioned, my name is Armando. I've been a data strategist and data scientist. I'm a co-founder of Ubhuru Technologies, when we provide their products to mid-sized customers. This is what we'll be exploring today. I will walk you through not only through what data science is, but why data science is so relevant, not only to organizations, but also to individuals who are looking to boost their careers. why data science is so important in all these digital transformation buzz that I'm pretty sure that everyone has heard of. But the question is, where does data fit into all these, and where does a data scientist fit into all these? So I will take a dive into that. And afterwards, once we set the context and we understand the reason why data science is so important, then we'll take a deeper dive into what are some of data science trends, talk about Internet of Things, edge computing, quantum computing, and we will start wrapping it up with a few use cases, real use cases of companies are leveraging on data science to boost their businesses and disrupt the industry. And finally, how you can upskill your talent in data science. So let's start with, what is data science? And data science is precisely that. It's a science. And in any science, the objective is to observe, understand patterns, come up with a theory, and communicate some results. Now, the difference is that data science today leverages a lot of data. So every organization now is ingesting tons of data. We are familiar with software and CRM systems, ERPs, and mobile apps. So we're ingesting a lot of data. And at the very end, we want to find what are some underlying reasons on why there are behaviors, whether in customers, in products, in prices, so that we can make better informed decisions. So data science is a process. It's a process of understanding what are the business problems that we can resolve with data, collect all the right information, all the right data, organize it, and very important, communicate it. A data scientist is, I don't know, some people say that data scientists are statisticians or are more similar to software developers, or even some to say they're more similar to mathematicians. But in reality, I think that a data scientist is more like a storyteller, someone that can link a business problem to the underlying patterns to drive actions and then communicate the story on how you go to the business problem to the solution through data. So visualization is extremely important. Now, how do we get all the way here? And why data science has been such a buzz, especially recently? Science, as you know, has been around for centuries. You have stories of visionaries like Tycho Brahe, who was a Danish astronomer, and his biggest contribution was data. So he would go every night to his observatory and just log, positions of stars and celestial bodies. And that was his main contribution. Because years later, other physicists, mathematicians, astronomers, they will take a look into that data that he would have collected through years and years. As a matter of fact, all his adult life, he will be recording that manually. But today, we don't have to manually record how long a phone call takes. We don't have to record manually how much someone buys. We don't have to manually record the distance between a transportation transportation device moving from point A to point B. All that now is recorded through electronic devices, pretty much through digitalization. Now, digitalization is also not new, right? So we have been with computers for a while now, but the problem is that computers before were very expensive. In the 1950s, just to lease 5 megabytes of storage will cost the company around $30,000 a month. Take a look at that. 5 megabytes of storage, $30,000 a month with IBM. Today, you can have terabytes of data in a thumb drive for, I don't know, $100, maybe $40, or I don't know, 30 euros. So storage has becoming way more accessible. Not only storage has become more accessible, but also compute. I don't know if you know this, but Intel's ASCII Red supercomputer that was developed in around the mid 90s, that had a cost of around like $46 million, has a similar compute power than a PlayStation 4 that you can get by $300. So not only we have grown our capacity to store data, but also how to process it, so that you don't necessarily need a huge data center to start doing data science. You can start doing data science in your laptops, which is amazing, which is really incredible. And not only that, the amount of data that humankind has been producing has also been growing exponentially. Just to give you a little bit of perspective on the last sentences about these 175 zettabytes of information. We already know what's a bit. Well, 0, 1, a byte, that is 8 bits, pretty much like a letter. We're gonna have a kilobyte, which is kind of like 180 to maybe 200 words. A megabyte, that would be a book of like 500 pages. We have a gigabyte, that is, if you have around 10 yards of books and shelf, there'll be 1 gigabyte. And in a large university, 100 gigabytes will be enough to store all the academic journals. Now, terabytes hold around 3.5 million images of 300 kilobytes. Or you can store in 1 terabyte 500 hours of good quality video. Now that's terabytes. We're still missing petabytes, exabytes, and zettabytes. It is said that the human brain has an estimated capacity of 1.25 terabytes. So that's a lot of information. 1 petabyte, if you have text, you would have 20 million cabinets full of text. There's like 500 billion pages, and that's a petabyte. Then when you have an exabyte, which can store about 1,000 petabytes or 1 million terabytes or 1 billion gigabytes, can contain 18,000 times all the information of all the books ever written. So if you take all the books ever written, multiply them 18,000 times, that is 1 exabyte, okay? Now, this is just to start figuring out how much data we're producing. Now, 1 exabyte is, 1 zettabyte is around 1,000 exabytes. So it is said that from some researchers that if you can record all human text or all human speech ever since we started speaking, we can store all that speech in 42 zettabytes of storage. So we have all these data, and the problem is that we don't have enough people to process and understand that data. That is the reason why this has been on the rise. You look on LinkedIn and you look at all the data science positions, and by understanding why we have so many data science positions in the market, you can have about 2 things. One is career growth, but otherwise, another perspective is companies are looking for data scientists. The question is your company looking for data scientists? Because if it's not, there's something that may be a little bit off in terms of your data strategy. So we have a lot more data out there than the one we can analyze and the one we can use to drive insights. And that is the reason why data science has becoming so relevant. Now, why is data science so important in digital economy? So we've already heard about this buzz of digital transformation, digital economy, digital organizations. So let's first understand what is a digital organization. A digital organization is an organization that can do something different or doing something differently by leveraging on digital technologies. Okay, now what are digital technologies? Digital technologies is the mix between your operations technologies and information technologies. Operation technologies is capturing observations, okay, in your environment, in your devices, is capturing all those observations, capturing when a user logs in, capture when you get a purchase, capture when someone clicks something. So it's capturing all those changes of state. And then information technology is using and presenting that information. But when you have a big data, when you have a lot of data, you need to have a way to translate all that data into insights and actions that can help you do things very differently or do things different, meaning to improve your performance by improving efficiency, effectiveness, and even throughput. And that is the reason why we're building now our strategies around digital economy, because we need data, and data is extremely valuable. Look at the largest companies today. Look at the Alibabas, the Tencent, the Googles, the Netflix. Their business, the Facebooks, the business is data. That is the reason why we are living in this digital economy. So the question is for you, are you really getting on board with this digital technology, digital economy? And the way to get on board of that is by performing transformations. So a digital transformation it's performing these quick shift from traditional ways of doing things to leverage your digital technologies, leverage your data to do something different, to enable your business to make better decisions, because you already have the observations that can prove why something behaves the way it behaves. You can also describe the way that your business is performing in a more holistic and rounded way. It's a lot easier to keep track of all your operations, whether your customers' behavior, your operations, your transactions, and also can give you perspective and context, understand the history, understand the context, so that you can start driving and making a difference in your organizations. There are some examples, and pretty much that some of you are already familiar with, like marketing and targeted marketing, hyper-personalized content. But we have tons of use cases, like in e-commerce, right? In e-commerce, we can do recommender systems, so that based on similar products, what are other products that can be bundled in, or based on behavior of other consumers, what you can position to the rest of your consumers. You can analyze your transactions to perform forecasts and to plan for budgets, to improve your investments. And also, you can understand the underlying reasons on why your consumers are behaving the way they're behaving. Because once you understand the underlying reasons, then you can start taking actions to improve your business. In logistics, very similar story. Look at Amazon. In their warehouses, they have these little robots that they will sort and dispatch different packages, and they use IoT, so all those devices are interconnected, and by using reinforcement learning, they define the best possible routes to stock and to rearrange or accommodate all different packages, so that the packages that are ready to be dispatched, they're the closest to the dispatch point, and that helps to improve not only the time to dispatch, but also square footage, because then you will not need that amount of storage, and you don't have to have a bigger warehouse, because you're able to move inventory around. You can also make projections on inventory. So at the very end, we do have a lot of use cases on data science. And again, data science is critical for digital transformation. It's cornerstone to thrive in this digital economy. Now let's look at some trends in data science. So first, as I mentioned before, if you look into LinkedIn or Glassdoor or any job search platform or engine, you will see that there's been a rise in demand of data analysts, on data engineers, data scientists, even business analysts, because the data scientists in large organizations, they really don't work alone, okay? Because there's a lot of data, there's a lot of requests from the business, and because business, they understand how important data science is, they bring people on board that can support all the data science process. So let's start from the very beginning, the business problem. Because what we're going to be doing is trying to figure out how to solve business problems by leveraging data. And this is when the business analyst comes into play. The business analyst can help translate the business requirements or business needs into data requirements. Things like, hey, you know something, we need to improve our margin in our sales process. We need to reduce our sales cycles, or we want to make sure that we target only valid opportunities. So that's the business analyst. So the business analyst will capture those requirements and will typically communicate with the data science team. Then you have the data engineer. The data engineer is the individual that will help bring all those data sources together such that the data can be ready for consumption by the data scientist and the data analyst. The data scientist is the one who will be taking all that data and start using mathematical statistical tools to find patterns underlying the data, understanding reasons, forecasting, and we'll put together a series of hypotheses that will later be tested by data in conjunction with data analysts. So the very end can be presented in the form of dashboards and visualizations. But you can totally see how the axis around all these is data, and how the data scientist plays such an important role in driving insights so that we can do forecasts and understand patterns that will help drive better business decisions. So before we get into these new developments related to data science, when we look into new businesses, and when we start analyzing why data has become so relevant, it's because every time that we capture, a transaction, we make an observation of a phone call or an incident, I mean a resume. So in HR organizations, you have resumes, you have interviews. Those data points are just snapshots of reality at a given point in time. They're not assumptions. They're just things that happen. There was a phone call. There was this resume. This interview happened. So we are really trying to make sense of reality. So we take all those different observations and we will start building theories around them. So we are not starting from theory, and trying to map it to realities all the way around. We're taking all those data points, things that we know that actually happened, to start creating statistical and mathematical models that will help us predict the future. Right? It's like having this crystal ball, this magical crystal ball. Now, if on top of that, you add how fast we have been evolving as society the last 10 years, even 5 years, you would see that there's been a growth in IoT. In Internet of Things, you have all these devices connected that can give you a great snapshot on how the environment looks like. And IoT comes all the way from agriculture, where you can have sensors that will track humidity and pH of soil and wind and temperature, that can automate when you need to, trigger sprinklers or where it's a good time to crop. You also have IoT inside data centers, when you have all your servers and network and even your components being tracked in terms of performance, so that if something fails, you know when it fails, and you can even predict when someone may actually fail. We had this very big customer that, using IoT and data science, they automated almost a full data center with self-healing capabilities, so that the only situation where someone will go physically inside the data center is if they would have a part to replace and they would know where to replace it. Everything else was self-healing by using IoT. And this is a trend that will keep on spiking and growing. Now you have wearable devices, and even when it comes to new technologies, you see that there is these new brain-computer interfaces when you can control, games with your brain. And if you wonder how was that even possible, well, data science was behind it. So as more of these devices start being, becoming mainstream, the more relevant data science is going to be. We now look at event-driven architecture and software development to capture all those events. Remember that when I told you about what is a digital technology, combination between operations technology and information technology? Well, from operations technology, when you want to capture all those observations across all your environment, well, now in software, there are event-driven architectures that will allow you to capture all those events, all those observations, so that you can understand patterns in how your consumers behave, understand how they interact with your system, so that you can even improve maybe user experience. You can improve your cross-selling capabilities, even offering new products, doing targeted marketing. There's also been a rise in natural language understanding. Natural language for us is the way that right now we're communicating. You see a slide with text, and I am speaking to you. But natural language is not that natural to computers. But now with advanced like BERT and GPT-3, we can actually have a conversation with a computer. Not the computer is conscious about the conversation, but it feels natural to us. So we can have a chat conversation with a computer, and you can actually see that in most platforms, right? Now, as an organization, you want to make sure that you provide to your service consumers this omni-channel support, so that there are multiple channels to reach you out, and one of those channels can be chatbots. And chatbots rely on data science so that they can understand text and you can feel like you're having a conversation. We also have image processing, right, for object recognition. That's happening across the board, from self-driving cars to defense, where you can have even in social media, right? That's what Facebook is doing. They do image processing so they can capture all the pictures where you're at, or maybe capture pictures where a product is showing, right, and get a context. So image processing is also becoming more and more relevant. And then I have machine learning operations. Machine learning operations, data science doesn't work alone when you want to roll it out into your daily operations. You definitely need to roll out all your insights and your models and your algorithms and embed them into the business. So that requires to embed data science into your operational function in your organization, and we find machine learning operations sitting there. Robotic process automation, and the robotic process automation can be simple when you code specific rules, like, hey, if someone selects yellow, offer these. Super simple. But as decisions become more and more complicated, we cannot hard code the rules. We need robotic process automation to be powered by data science, so that complex decisions can be made and can be automated. And when autonomous devices, we have like a combination of all these, right? When you look at self-driving cars, there's a combination between image processing, IoT, event-driven architectures, machine learning operations, and even robotic process automation. And autonomous devices, there's this race because organizations, they see how profitable, how successful autonomous devices investments are going to be. But this also raises some new topics to discuss that we have never discussed before, which are things like our rights as digital citizens, what's going to happen to our data, what's going to happen to our customers' data. And then you have regulations like GDPR, GDPR, like HIPAA, like CCPA, where organizations see how data and the use of data can get out of control. So that's the reason why we need more professionals that really understand the implications of using data to the benefit of humankind. So rights of digital citizens, it's also becoming part of the conversation, same as AI ethics. How do we avoid bias? Because even the fact that data science has been proved to really boost our performance as humanity by discovering new vaccines and new ways to do things, it can also enhance our biases. So potential future applications, you will find, this constant intelligence, this continuous metadata. It's the data associated to the data. So if you take a picture, the picture for us is an observation, but there's some metadata associated to that picture, like when was it taken, where was it taken, the device where it was taken from, and all that metadata creates more data for us to make analysis and also capture insights. Something that is right now very, very popular is edge computing and hyper-personalization. Edge computing means instead of running the compute in your servers, you can run compute closer to the consumer, maybe in their cell phones or in their computers. Running very complex decision-making algorithms can be very compute expensive. But when we have a data science model or machine learning model that was created by data scientists, edge computing becomes at a reach of our hands, which will make the overall experience for your users and consumers a lot better, because they will be able to process a lot of information in their devices. Just look at your iPhone or like Pixel. You think, or people think, that most of the data goes to Apple or Google, it's processed there and then sent back to your device. Well, to be quite honest, that doesn't happen most of the time. Most of the time, the actual predictions and the voice recognition happens in the device without you having to communicate with Google or Apple. And then we have hyper-personalization. This is one of the most evident applications of data science. You go to Amazon, and do you know that in some situations, Amazon, they will know what you're going to buy before you know it? Because it's hyper-personalized. They know your patterns, and it's important for us to understand how our consumers behave so that we can anticipate their needs, so that when they need something, we're already prepared because we understand their context, and we can personalize the support and the delivery for all the different consumers. Then we'll continue to digitize analog information to better analysis. And something that will happen in the next few years is leveraging on quantum computing for artificial intelligence and machine learning. Meaning that as a data scientist, you will recommend specific models, but as we'll be moving forward, there are a lot of things you need to fine tune as a data scientist to have an ideal model. With quantum computing, that fine tuning will happen so fast and so cheap that the growth of data science will be exponential, even exponential to what it is today. So there are some things to keep an eye on. Now, there are definitely benefits, a lot of examples that you should be already familiar with. Netflix is one of them. Netflix, for the ones that don't know, Netflix, they crowdsourced the first algorithm. So they open a competition. Say, okay, whoever provides the best recommender system, the algorithm will be brought on board into Netflix. Netflix disrupted the whole entertainment industry by leveraging on digital technologies. That is digital transformation. So Netflix was born as a digital organization because they are able to perform something very different to the rest of the industry, the entertainment industry, by leveraging on data. So they have data, and they have data scientists that will analyze and try to understand what is a movie that you may like, or documentary or series that you may like. So you can see that data science is not only really applicable, it's profitable. And for the ones that are more in, I want to create an impact in humankind, data science is being used to address things like poverty, hunger, vaccines, amongst other aspects that are causing huge social impact. And then you also have YouTube, right? YouTube is super interesting because they have a mix of everything. First, they use a lot of image recognition and video recognition so that they can automatically filter censored content. So don't think that there's people all the time and the only thing that they do is to filter and censor content. So YouTube, they actually have algorithms that will point out what are some possible videos that have unapproved content automatically. They can also understand which videos are shown to whom so that they can start embedding marketing materials like targeted marketing. And also trying to understand what your preferences so that they can show you more videos like the ones that you like. You go to my YouTube channel and you will see like all sorts of like data science, astronomy kind of videos. You go to my wife, she's an artist, and they'll be like all about art and trends and visual arts. So this customization happens because there's data science in the back end. You have other applications like face recognition, cameras, powered by government, logistics, and even dating apps. There is, believe it or not, a lot more of data science and machine learning affecting your lives than what you even think. Data science is all over. The question is, are you part of it or not? And not part of it as a consumer, but part of it as someone creating a transformation in your organizations as part of this, revolution in digital era. Let me bring you one amazing case study. So there was this data set collected for about 15,000 employees. And the question was, why are they leaving? And before I make this switch, I just want to emphasize on something. What I'm explaining here in this slide is all external. So we actually see how companies are benefiting from capturing consumers and capturing business. But data science does not only apply to capture business. It also helps to understand why things happen inside our organizations, like in this situation. For HR organizations, we know that it's a painful process every time that an employee leaves, especially if you have a good employee. So it is extremely relevant for organizations to understand how to retain talent. And there was this study on why employees leave. So we have this data set of 15,000 employees, 15,000 observations, and there are multiple columns, right? For every employee, there was information about their overall satisfaction level, the last evaluation, projects completed, time spent, if they were, of course, still in the company or not, salary, they've been promoted, and so forth. They've had accidents or not. So what's this data set? And using this data set, the question was, how do we retain employees and why are they leaving? Because we cannot make any decisions to retain employees if we don't understand why they're leaving in the first place. And again, that's where data science comes into play. So a data scientist jumped in and said, okay, let's make sure that we understand the data. We can do some exploration to try to find out what are some patterns, how data is related. We'll do a detailed analysis, and then we'll start performing machine learning to do clustering and then to model the data so that we can predict if an employee might leave or not. At the very end of this project, if an employee would fill out a specific survey, or the organization would capture all this information on an employee, you would get a score with the likelihood of that individual staying or leaving. And the overall performance of the algorithm was really high. So the best algorithms are able to predict if an employee will stay or leave with some like 99.95% of accuracy, which is huge. So when the data scientist or data scientist team started analyzing the situation, this is kind of what they show to executives. Right? They say, okay, first, there are top factors why employees leave. And the fact that job satisfaction is important, in reality, what is affecting the most is the number of projects that they have assigned. So some people, they would think that it will be promotions or salary, the main reason why employees leave. But the funny thing, it was not. They were not complaining about salaries. They were not complaining promotions. And by the way, don't think that this company was paying tons of money to the employees. It's average organization. But after making the analysis, they found out that it's not a matter of investing maybe in recognition or in salaries. People were leaving because they were feeling burned out. So once a data scientist was able to understand the threshold of that burnout, it's easier to embed an algorithm into an HR system, such that when a manager assigns work to an employee, they can get an alarm saying, hey, if you continue to assign workload, you will have 60% chances for this employee leaving in 6 months. Imagine how useful something like this could be to any HR organization. And there are even some additional aspects, right? Like not only if employees will leave, but how do you select the best resumes for hiring? So all these solutions can be powered by data science. Now, I know that data science sounds like super amazing, and but then the question is, how do I take this to my executives? How do I get buy-in from my executives so that we can start our data science initiatives? And there are very tangible ways to measure return on investment, because data science and overall will help you with three things: whether to improve efficiency, effectiveness, or productivity. Effectiveness meaning that what you promise to deliver meets the standards of quality. Efficiency, that you're able to maximize the use of your resources. Or productivity, so that you can improve your throughput of work. And you can put that in the context of revenue, on time to market, on team efficiency, on utilization of hardware resources, logistics, or even to be competitive to gain more market. So measuring return on investment in data science is really not that hard. You have a baseline, you have a benchmark, and if you can hypothetically increase the performance, how much savings or how much revenue we get. And that's how you put together our return on investment analysis. Okay. Now, just in case it's not clear, right? Now, why it's so important for you to get on board in data science? Well, because you want to make sure that you prepare, whether yourselves, because this will be the skill of the future. So, and also to make sure that your organization can accomplish its vision a lot sooner and better, and in a way that it's way more competitive in these very competitive landscape that we live today. So make sure that you define business objectives. That's the most important step. What are the things that you want to improve? What are the things that you want to do different? How are you planning to bring a detailed experience to your stakeholders, whether internal or external, whether consumers or internal customers? Now make sure that not only you define your business problems, you define your objectives, what you want to perform, how do you want to transform to get on board in this digital economy, but make sure that you understand what are the capabilities that you have currently today in your team. Capabilities in terms of data and also in terms of skills. So perform this gap analysis. This is your current state, your snapshot. This is your end state, having a full data science team that will boost your organization's performance. So what is it that we need to go from here to here? And then you can start figuring out smaller initiatives that will be packaged in data products that you can implement and later leverage to, improve performance. Now, where to begin, right? So, where to begin? Again, there are different approaches, but we'll give a recommendation on what is the best path for you to begin to get on board of these, data science opportunity, or this new data science driven world. Right? So data scientists and sometimes may require advanced degrees, but with common libraries being used, with enough mathematics and high school statistics, you can actually start getting on board with data science. Skills are required for data scientists will be some level of math, calculus, algebra. Algebra and calculus are the most important. Statistics, distributions, probability, and I think that's pretty much the gist of how deep you will go in terms of mathematics and statistics. Of course, the more understanding, the better. And programming, you cannot do data science in an Excel spreadsheet. So you need more powerful tools like Python or R to start analyzing huge amount of data. And a very important skill, storytelling. Because data scientists, besides being scientists, they are storytellers. You need to communicate your story, the reasons why, the benefits, the advantages. Not everyone will speak your language, your data science language. Not everyone will be as savvy as you in mathematics and in statistics. So you need to figure out how to drive a message that will resonate with everyone in words, to drive elegant communications, to be able to position a very powerful message in simple words. And also, another path is going through data engineering. Now, data engineering refers more on how we will be ingesting the data, how we'll be sourcing, extracting information from multiple sources, transforming so that it's consistent, loading it for distribution and consumption. So they work a lot with cubes, warehouses, architectures, and of course, you're also familiar with programming languages, maybe not Python, maybe not R, but maybe SQL. Okay. And this is where ILX comes to play. So ILX offers all that. ILX offers a comprehensive path to become data scientist, data engineering, or to get into data analytics and business analytics. And by the way, don't be spooked for the fact that you require mathematics and statistics. ILX, in partnership with Simplilearn, provide the tools and the paths so that you know what is it that you require so you can onboard and you can start your data science career. Now, it can be costly to recruit and hire data scientists and data engineers, but there's a different path. Instead of hiring data scientists and data engineers, why not upscaling your skills and broaden the perspective of your teams, power them so that because they have the understanding on the business, now they just need to get on board with what is data science, how to drive insights from data, and you already have people that know the business. Because there's this huge gap. You have great data scientists, know data science, but they don't know the business. You have people in the business that know the business, but not data science. But you can be both. You can be that unicorn that understands the business and can drive better solutions and insights with data science. Okay? With ILX in partnership with Simplilearn and through our trainings, you don't only get the top-notch, state-of-the-art content, but you get multiple ways of engagement. You have live presentations, you have projects, you have initiatives. You will be shared with data sets with proven trainers that have experience, like business, real life experience in data science that can address business problems. Right? And this is just kind of a sample solution, a track record of the path to become a data scientist. And if you can see from the track record, not only it's comprehensive by providing tools like understanding Python and programming languages like R, again, and Python, but also to get into statistics all the way through understanding machine learning so that you can have this holistic, well-rounded profile. And this powered by top quality trainers, by labs, by live projects, by reference material, and very important, by the engagement of hundreds of people that are putting all their effort to keep the material up to date and relevant for the most updated or most relevant and current problems and technologies, problems that we face and technologies that we can leverage on. So today we covered the story of data science, so what's relevant, what's important for data for transformation, how data-driven decisions have become so relevant to drive performance, what's the evolution of data science, real applications, and how to develop your personal skills and how to move your organization to become a digital one. So I would like to pass it over to Sally.
Wow, thank you so much, Armando. That was a real whistle-stop tour on data science, so thank you. So to all of our listeners, if you are interested in getting on board with data science, today was very much a sort of a taster, an introduction, but please do get in touch with us. If you go to our website, you can see all the details on the screen. You can have a look at all of the different learning tracks, learning programs pertaining to data science and other technical curriculum areas as well. If you would like to talk to us, then please contact us on the contact us email address or the telephone number that's on the screen. I would just like to conclude by saying thank you to you, Armando. Thank you to all of our listeners. We have got 7 or so minutes left. So I'm going to pass you over to Alice. And Alice, hopefully you have some questions. If you haven't pinged over a question, please do. We still have time. And hopefully in the next sort of 7 minutes, we'll answer as many of those as we possibly can. Thank you.
Cool. Thanks, Sally. Couple of questions. I'm just going to start with some of the more kind of direct ones. So for those who are new to data science, Armando, which training course would you recommend for a beginner?
I would recommend, so if you look at the track path, this pretty much explains where to get started. So it started with what is data science for, then a little bit of statistics, and get started with programming languages, going through data science, machine learning, and then visualization. So I think that this slide kind of gives a sneak peek on where to get started.
Brilliant, thank you. A bunch more questions come through now. Someone has commented earlier on that edge computing looks like it's backtracking somewhat from cloud computing. So they're not quite sure how to understand why this partial reversal might be taking place.
Okay, because cloud computing, you will be using it for things like training your models and training algorithms and doing the analysis. But once you have trained the model, you don't want to leverage on that compute and those servers to do the actual predictions. So once the model is trained that requires a lot of compute, the model can be installed in device so that you make your resources utilization more efficient. Have intensive in your data center, not that intensive on device.
Brilliant, thank you. Next question. Someone's asked, what are the biggest challenges or barriers that organizations face in adopting a data-driven approach?
The biggest challenge is bridging the gap between the knowledge of a data scientist and the business problems. I've seen organizations hiring PhDs in data science, and then the PhDs are just crashing the bellies trying to find out what to do. And then the business, they're struggling with a lot of problems that they don't know can be solved with data science. So the biggest challenge that I've seen is having people in the business understanding data science and getting data science, a little bit of data science training or education.
Oh, thank you. Is Power BI used in data science? Someone said we've only talked about Python and R programming.
Yes. So the way that a data scientist will communicate findings vary. There are tools like Tableau, Power BI, even some Python-related tools like Bokeh and Plotly. So those are visualization tools that data scientists will use to present the results or even to present predictions.
Oh, amazing. Thanks. Next question. What are the industries that have been most impacted by applying data science?
I think all of them, but I think the first ones were marketing. So I think marketing is where we saw the boom in data science and artificial intelligence, social media, and now logistics. But I think at this point of time, it's every industry. Logistics, consumer products, transportation. I think that today, if an organization is not already leveraging on data science, it's sooner or later, well, they will not be competitive enough and will be taken over by companies that are leveraging on data science.
Cool, thank you. And another question, we've talked about this, the slide you've got up at the moment, the sample solution talks about a learning path. What exactly do we mean by a data science learning path, essentially?
I can maybe answer that. So it's really a combination of courses, and all of the online learning content is accessed and consumed online, either through the ILX Simplilearn portal or through your own LMS. But rather than thinking of just coming on one course, a big bang course, it's literally you are attending live virtual classes which are instructor led, and you're also doing your own self-directed learning through the e-learning modules as well as you go. So you go through a learning journey which comprises of all, for example, of these courses here. And then there is a sort of almost like an end point sort of where we release a certificate when you have completed the learning track. Yeah, I think the completion rate is 85%, and you've applied the learning to the various sort of projects and labs that are part of that learning program. Hopefully that explains.
Yeah, no, that's great. Thank you, Sally. That's all the questions currently. Just to reiterate that we will be emailing out a recording of this webinar tomorrow in an email for anyone who missed that at the start. But yeah, those are all the questions. Thank you everyone who submitted them. And thank you again, Armando. I'll hand back over to Sally.
So I don't think there's anything more that I want to say other than thank you everybody for listening. And once again, if you do require any further information from us or any support or want to have a conversation or interested in getting on board with data science and upskilling within your organization, then please reach out to us and we'd be more than happy to help you. And thanks everyone for your time today. Thank you, Armando, and enjoy the rest of your afternoon and evening. That's goodbye from us here at ILX and Simplilearn. Bye-bye.
Thank you. Bye.